A data center is something where you put your network, servers, operating system, etc. For data centers, infrastructure include the land as well, where data center is built, the building which houses the data center, physical security of building, for example, security guards and all, electrical equipment, etc., etc., and a lot more. On top of it, we have network, storage, servers, virtualization, operating system, database, security, application. Now, let's see how infrastructure as a service works. In this case, data center, network, storage, servers, you have the exact same thing, operating system, database, security. Now the blue portion is something which you manage and control. That is your responsibility. And the gray portion is something which is managed, controlled, and maintained by the provider. So in this case, if you see an on-premise data center, everything is blue because you have to maintain, manage, control everything except for network, which has both blue and gray portion, because you have to get your network from some or the other internet service provider. But in this case, in infrastructure as a service, the data center, the network, storage, servers, and virtualization layer, till here you do not have anything. You use someone else's infrastructure. On top of it, you install operating system, maintain it, maintain its patches, security, and everything. You can install database. You are responsible for security of your application, database, operating system, etc., etc. But security and management and maintenance of the bottom layers like data center, network, storage, server, virtualization are handled by the service provider. What about platform as a service? In case of platform as a service, you just use the platform. You don't care about the underlying infrastructure or how the platform was made. You just use the platform, code on it, and create your application. So in this case, data center, network, storage, servers, virtualization, OS, database, security, everything is provided, controlled, managed by the service provider. You control, manage only the application which you create, which you use the platform to code your application. So the security of the application will also be managed by you. Then finally, software as a service. In case of software as a service, everything is managed and controlled by the service provider. You just use it as an end user. All right. Now, these are the different service models. First one is on-premise, then infrastructure as a service, platform as a service, and software as a service. And this is how they differ. Let's see the different deployment models. So we have public cloud, which is AWS, Microsoft Azure, Google Cloud, IBM Bluemix, etc. So why it is public cloud? Because you can use internet to access their services. Right? You have internet. If you have internet connectivity, you can use that internet to log into any of the service providers environment and use it. So as internet is a public resource, that's why it is called public cloud. Then you have private cloud. HPE, VMware, OpenStack, Dell EMC, etc. fall in the category of private cloud. Now, why it is private cloud? You get the entire cloud platform, as in virtualization of compute, network, storage, and everything. Then instead of internet, you'll use intranet. So as long as you are in network and you are connected, you are using cloud. So in this case, you are using intranet and virtualized environment. So you are using private cloud. So hybrid cloud is something which is a combination of both. So you have private cloud environment on your data center. Then you have public cloud. You're using either AWS or Azure or Google Cloud. And then you connect both of them to create a hybrid environment. So a lot of corporate environments or enterprise environments use this hybrid cloud environment. This is in fact the most famous. There are no hybrid cloud service providers. You have to use a public cloud service provider and a private cloud service provider, and you combine them both to create a hybrid environment. Now, why should we use cloud computing? What are the different advantages over on-premise? So suppose, let's see how capacity is provisioned in on-premise data center. So on x-axis you have time, on y-axis you have capacity. So capacity can be anything. It can be CPU, it can be RAM, it can be network, it can be file system, anything. Okay, suppose this is your usage. You have Monday, Tuesday, Wednesday, Thursday, Friday, all 7 days in a week, and this is how your usage is, how your application usage is. So on Monday it's pretty okay. Tuesday it's high. Wednesday a little lower. Thursday again a little bit high. Friday highest. Saturday, Sunday pretty less. Now suppose you are talking about, say, CPU. Now if you have to buy capacity or CPU, you have to buy at this layer. That is one option. So buy CPU or buy capacity as per the highest requirement. But there's a problem here. These portions are unused. So you have bought capacity, but in most of the cases, in most of the days, in most of the times, you are not even using 100% of it. What is the other option then? The other option is buy out average capacity. This is more problematic because on these days you have less capacity, so your performance will hamper like anything, and you cannot afford to do that because you lose customer and you lose business. This is where cloud excels. You need different capacity on different days, maybe on different hours, or maybe per second basis. Your capacity changes as per your need. So you use whatever you need and you pay whatever you use. So in case of on-premise, in the first scenario, for this one, you have to buy CPU and you have to pay for, say, if you need, say, 5 gigahertz on Friday and less on the other days, you'll have to buy a CPU and you'll have to pay for that 5 gigahertz, whereas you are not using that 5 gigahertz at all. In this case, you are buying on average usage, say 3 gigahertz. But if you have problem on the other days, again this is much more problematic than the previous case. But here, if you are using different CPU speed on different days, you pay for it. So basically you lease it out, or use that infrastructure from someone else, use CPU provided by someone else, and you pay them as you use. So if you're using, say, 2 gigahertz on Monday, pay only for 2 gigahertz. If you're using 3 gigahertz on Tuesday, pay only for 3 gigahertz. On Wednesday, if you're using, say, 1.6 gigahertz, pay only for that. So you're using a lot of money, just by switching to cloud computing, and that's why it has become so famous, because of this cost savings. What are the other advantages? We do not have any capital expenditure whatsoever. So remember, three slides back, we discussed what a data center in your on-premise data center, environment contains. It contains a land, a building, security, electrical equipments, security guards. On top of it, you have servers, operating systems, etc., etc. Now, if you are using someone else's, you do not have any capital expenditure because you don't have to buy land, you don't have to construct building, you do not have to lay out any electrical plan. So you are using someone else's, so you have zero capital expenditure. So zero capex. Then everything is charged on per second, minute, or hour basis, and pay only if you use. So the second, minute, and hour depends on which cloud provider you're using. Either you are using AWS or Microsoft Azure or Google Cloud. But whatever cloud service provider you're using, you'll be paying on the per second, per minute, per hour basis. So on a 24-hour day, if you're using CPU for, say, only 3 hours, you'll be paying for 3 hours, not more than that. Then getting a new server is very easy as clicking some mouse buttons. So if you're from corporate data center background, you know that provisioning a new server might take somewhere between 1 week to 4 weeks. Here, you can do that in minutes. Maybe if you're fast and clicking mouse buttons, you can do that in less than a minute also. And provides very high available solutions without any extra effort. So if you're using any cloud provider, you're getting high availability without any extra effort whatsoever. You just have to use it. That's it. Then security. So security of the infrastructure is offloaded from you to the service provider. So when I say security, I mean from the bottom up. So you have land, so you have to have legal documents for your land. Then you have, when you construct building and put data centers there, you have to have security guards. You have to have controlled access throughout the data center. Now you do not do that. That is managed for you by the service provider. Then finally you have flexibility and error shield. What is this error shield? So think about the previous diagram wherein we saw how capacity can be provisioned. It can be provisioned at the maximum level or an average level. Suppose you have analyzed your application and you found out that your application would need, say, 2 gigahertz of CPU and say 10 or 16 GB of RAM. Now, after getting those servers, after getting the resources, you find out that okay, this is not the case. You need much more. You need 6 gigahertz of CPU, and you need maybe 256 gigs of RAM. So you go to management, and then of course, if you're from infrastructure, you might get blasted because everything was done. It took a lot of time. You had to follow a lot of process. Then you got those infrastructure in place. Now you need some more, right? So you have to go through the entire process again. It will take much more time. But here, if you have done something wrong and you find out, you can change that in minutes. So that's what error shield is. You can over provision, not a problem. You can take it down or tone it down. If you under provision, not a problem. The moment you figure out that you have under provisioned your capacity, you can tone it up based on your requirement in minutes. So let's see an analogy how to map your corporate data center or enterprise data centers and AWS services. So you have server, which is basically CPU and RAM. Then you have something called storage. So you attach that storage to server and you get a box. So typically this box is something which you call server. And you can install your database here, you can install your application here. The choice is yours. So you install multiple things on top of your server or the box and you put them behind a network, right? And to control access, you use firewalls in front of your application or in front of your network or in front of your server. Then you have a set of users. You have a set of external users and internal users. External users are the one, basically your product users, and internal users are the users who maintain and control or manage your infrastructure. So you allow users to access your network. So if you have external users, that means you have some URL also, you have some website also. So you get a domain and you connect your domain to the servers on your corporate data center. Now you have to take care of everything so that nothing goes down. So you have to monitor, right? So you have to have a big boss which monitors each and everything. So this big boss should monitor and both proactively and reactively and notify the concerned person that if something is wrong. So the notification can be done using email or pager or something else. Now let's see AWS, how you map AWS services here. So instead of server, we use EC2 instances, right? AWS is EC2 service. So instead of storage, you can use multiple storage services like EBS, EFS, etc., etc. and attach those things to your EC2 instances. So instead of database, you can use DynamoDB or RDS. Right? You can, instead of network, use VPC, which is AWS's network offering. So you can create firewalls using security groups and network ACLs. So if you are using users, instead of user access management, you use AWS's IAM service to create and manage users and groups. So earlier you had domain. Instead of having a third-party domain provider, you use Route 53. So using Route 53, you do the exact same thing. You route your internet traffic to your data center. Now in this case, the data center is behind a network which was created by VPC. You are using EC2, you are using EBS, you are using AWS's database services, etc., etc. Then to monitor all these things, you get something called CloudWatch, which monitors A to Z of AWS services. And as I said earlier also during the topics, you have integration with SMS. If something goes wrong, you can send notification. Alright, so this is how you map components of your corporate data center with AWS services.